back, young scholars. We're looking at systems of inequalities. Remember the inequalities? You may have to go back and review that video. You're going to look at two inequalities with two variables. Usually it's x and y. You're looking for the set of ordered pairs that satisfies all of the inequalities in the system. You're looking at the overlap. Where do these two inequalities intersect with each other? So you're going to correctly graph the two inequalities on the same coordinate plane and then determine the points they share. For teaching purposes, I'm not going to overlap them so that you can understand the information a little bit better. But when you do your homework, you can put them on the same coordinate plane and overlap them. Example, we have this system of inequalities. If I graph y is greater than negative 2x plus 1 and y is less than or equal to x plus 3. If I graph this one and I graph this one, you see the two graphs. What I'm looking for is where do they share the points and intersect. This graph would include this area, but they don't share it. This graph would include this area, but they don't share it. The only thing they share is this area in here, so I would shade that in and indicate that is the ordered pairs that satisfy both inequalities. Another example, y is less than or equal to 3, x plus y is greater than 1. If I graph the y is less than or equal to 3, I get this graph. I converted this into slope-intercept form so that it's easier to graph. You may have to go back and review that video. And you can see this is what would be shaded, this side of the inequality. But when I combine the two on the graph, the only thing they share is this section right here. So you'll indicate that on the graph and say this is it. Now this part is also the y is less than or equal to 3, but we're not shading it because they don't share those points. Another example. You need to keep this one in mind here. We have parallel lines. When I take this system of equations and convert them, we see they're parallel lines with the same slope, just different y-intercepts. When I graph this one, it's on this side. When I graph this one, it's on this side. When I put them on the same plane together, they share no common points. So therefore, in this one, the answer is no solution because they're shaded on opposite sides of the parallel line and they share nothing. The next one, though, is a different story. Here we have these. When we convert them, when I convert the second one into slope-intercept, they're parallel lines. 2x plus 3, 2x minus 1. The only difference is the intercepts. When I graph those, though, they do share. This one will be graphed and it's shaded on this side. This one's graphed, it's shaded on this side. So they do share what's in the middle. So everything here would be the solution set to these ordered pairs. So keep that in mind. Fortunately, this is the last one for this unit. Hope we do well on our semester exams and everything, and I'll see you next semester.